Asante everyone, we are Group 3. We are here to discuss this topic as part of marketing research. But first, I would like to introduce to you my group members, Mr. Baldemor, Miss San Juan, Mr. Santamena, Miss Supan, Miss Velasco, Miss Vargas, and of course, yours truly, Miss Villania. To explain the first topic, which is the sampling method, let's hear Miss Vargas.
Good day everyone! Today I will discuss what is the sampling method, why is it needed, and what is the importance of it. In research, sampling methods refer to the processes used to pick a subset of individuals or items from a larger population to study, with the goal of deriving conclusions about the overall population based on this smaller sample. On a simple explanation, it is a process of selecting sample population from the target population. For example, if you are researching the opinions of students in your university, you could survey a sample of 100 students. Before I discuss the importance of the sampling method, there are different kinds of sampling methods such as random sampling. In this method, each member of the population has an equal chance of being selected. The second one is the non-random sampling. It is a method of selecting units from the population using a subjective method. The third one is the stratified sampling. The population is divided into subgroups and then random samples are taken from each stratum. This ensures representation from each subgroup. The next one is the systematic sampling. Researchers select every individual from a list of the population. The next one is the convenient sampling. This involves selecting the easiest or most readily available subjects. Next one is snowball sampling. This method is often used in studies involving hard-to-reach or hidden populations. The last one is the cluster sampling. The population is divided into clusters and a random sample of cluster is chosen. Then, all individuals within the selected cluster are studied. So let's discuss why a sampling method is needed in research and why is it important. Sampling in research is important for several reasons. The first one is cost and time efficiency. Sampling allows researchers to collect data in an effective and practical manner. The second one is reducing bias. Proper sampling methods can help reduce bias in the selection of participants. The third one is the precision. Sampling can provide precise estimates of population's parameter with appropriate statistical technique. The next one is ethical consideration. When conducting research on sensitive or vulnerable populations, sampling can be a more ethical method. It can assist protect people's privacy and well-being. The next one is the practicality. When the population is too large or distributed or the research requires destructive testing, sampling method is the only one that is feasible. The last one is the variability. Researchers may examine and comprehend the heterogeneity within the population by examining a sample, which is critical for making educated decisions and predictions.
One of the most effective ways to conduct market research is sampling. For you to draw legitimate conclusions from the results you obtain, you need to make a careful decision on how you select a sample that represents the group as a whole. There are primarily two sample techniques used in data collection. These are random sampling and non-random sampling. To define what random sampling is, so random sampling, also known as the probability sampling, it includes random selection to draw statistical conclusions about the entire group. So when using random sampling, you start with a complete sample frame of all qualified individuals who have an equal chance of being included in the selected sample. So as a result, they must not significantly differ from unsampled observations for the selection to be considered random. So here is an example of random sampling application, a research that talks about the role of menu descriptions in enhancing the customer satisfaction. So for the data collection, the researcher will randomly select consumers to survey about the role of the menu descriptions to their satisfaction. So the respondents that will be randomly selected are meant to be unbiased representation of a group. Let's proceed to non-random sampling. So non-random sampling or the non-probability sampling is a technique for selecting units from a population that is subjective or not random. So non-probability sampling is a quick, easy, and inexpensive way to collect data because it does not require a complete survey frame. So however, in order to derive conclusions about the population from the sample, it must presume that the sample is representative of the population. With this form of sampling survey, you exclude a certain amount of the population in the sample and you can calculate that exact number. So this sampling method uses groups that are a bit more deliberately structured. So this means there are limits to the amount you can determine from the sample about the population. To give you an example of non-random sampling approach, so a research about the lifespan of selected businesses in Santa Rosa. So when conducting this type of study, the researcher would choose the target respondents or businesses in the Santa Rosa area only, based on their qualifications, convenience, and judgment. But because you only surveyed Santa Rosa firms, your sample does not accurately reflect to all Laguna's businesses.
A random sampling approach is one in which each member of the population has an equal probability of being chosen for the sample. This is accomplished by selecting participants from the population using a random number generator. Random sampling is necessary to ensure that the sample is representative of the population and that any conclusions obtained from the sample may be extended to the entire population. While non-random sampling is a sampling approach in which not every member of the population has an equal probability of being chosen for the sample. This is due to the researcher choosing the sample based on criteria other than random chance, such as convenience, judgment, or experiences. Non-random sampling is frequently employed in exploratory investigations to gain a general knowledge of a phenomenon. It is crucial to highlight, however, non-random sampling might result in bias, and that any conclusions taken from the sample should be evaluated with caution. The image you can see behind me demonstrates the following fundamental distinctions between random and non-random sampling. In random sampling, there is no bias or biases. There is an equal opportunity to participate, and lastly, researchers can draw statistical conclusions from participation, while in non-probability sampling there is an equal participation opportunities. It is convenient and data collection is simple. And additional to this, the image you can see behind me shows that random and non-random sampling, the random and non-random sampling methods of random sampling, basic random sampling, random stratified sampling, random sampling in clusters. While in method of non-random sampling, there is sample convenience, snowball testing, and portfolio sampling. Thank you.
This is the similarities of random sampling method and non-random sampling method. First is techniques in data gathering for research. Both of these research methods are used to gather data to support research it will be used. Next will be it has the same purpose because I've said it is used to perform research and enable to gather data, but of course, in a different manner which each of it has its own nature. Next will be the presentation. Both of these sampling methods are going to gather data, and of course, they will be presented, but it will be depending on what research will be researcher to be conducted. For example, in quantitative research, it will be represented as a graph, while in qualitative research, it will be represented as in a paragraph form. Next is providing sample that will go alone to answer the research question under evaluation. As it's gathering information, it will be providing some insights to answer the research question, and this answer will be evaluated to get the result. Next and last, generalizability of issues to an external situation or population that is for external validity. So this method can also stand as validity evidence that research is carefully and methodically studied, and it can solve some or almost external issues in a way to use right type of sampling method.
As a continuation for the research sampling presentation, the next topic will be the sample size determination. Sample size determination in the context of research and statistics is the process of selecting the number of individuals or elements from a population that will be included in the study or survey. This decision is critical because the size of the sample directly affects accuracy, reliability, and generalizability of the study's findings. Next is the guide or some steps in determining the sample size. First will be to define the population size and number of people. So let us start by identifying the size of the population that we want to make inferences about. This is the total number of individuals or items that your study is focused on. Understanding the population size is the foundation of correct sample size calculations. And next will be the designation of your margin of error. Margin of error or MOE is the maximum amount which you are willing to allow your sample size to differ from the true population values. So this usually is expressed in a percentage, and the common MOE is 5%, but you can adjust it based on your study's requirements. Next will be determine your confidence level. Confidence level is often denoted as 1 minus A and represents a level of confidence that you want reliability of your results. And common values are 95 to 99%, and this means that if you were to conduct the same study multiple times, you can expect the results to fall within the margin of error of 95 or 99% of the time. Next is to predict expected variance. The expected variance refers to the degree of variation of your data. And it's necessary to estimate how much your variability exists within the population that you are studying. If you have historical data or pilot study results, you can use them to estimate the variance. But if not, you can make educated guesses and make inferences to have a rational guess in your study. Next is to finalize your sample size. Once you have the above parameters, you can use the sample size calculators or formulas specific to your research design, such as proportional estimation or mean estimation, to determine the required sample size. Commonly used formulas include those estimating proportion, means, and comparing groups. But alternatively, you can use statistical software, online calculators, and other tools to simplify this process. Next, let us move on to the importance of sampling size determination. Sample size directly impacts the accuracy and reliability, also the generalizability of the research findings. That's why finding the right sample size is crucial for every research project. And the goal of research sampling determination is to strike delicate balance on researchers where they seek enough data and to draw meaningful and statistically significant conclusions. This means ensuring that the sample is large enough to detect real effects and relationship within the population. So these are the things you should keep in mind in selecting your sample size.
Sampling is when take a sample from a population and we make observations about the population using the sample that sometimes create errors or biases. Sampling error is statistical error that arise when a sample does not truly represent the entire population. There are differences between the real values of population and values derived by using samples from the population. Example of sampling error: suppose the producers of company XYZ want to determine the viewership of a local program that airs twice a week. The producers will need to determine the samples that can represent various types of viewers. They may need to consider factors like age, level of education, and gender. For example, between the ages of 14 and 18 usually have viewer commitments, and most of them can spare time to watch the program twice weekly. On the contrary, between the age of 18 and 35 usually have tighter schedules and will not have time to watch TV. Hence, it is important to draw a sample proportionally, otherwise the result will not represent the real population. These are the types of bias. But to sum up, bias on the other hand when the method of selecting a sample from a population is fluid in a way that certain groups or characteristics are overrepresented or underrepresented, leading to inaccurate or skewed conclusion. Example of this: in a marketing survey conducted by telephone, individuals without access to landlines or mobile phones are excluded for the sample. This leads to a sampling bias because the sample does not represent those who rely slowly on the other forms of communication, such as internet messaging apps, thus biasing that results in favor of those reachable by phone.
Sampling error. Sampling error is like a natural variation. Imagine you take a multiple random samples and each one gives you slightly different result. Sampling error is a small differences between these sample results due to chance or randomness. On the other hand, sampling bias. Sampling bias, this is more like a systematic mistake. It happens when your sampling method favors one group or characteristic over others, leading to consistently skewed result. It's not due to chance, but how you selected your sample.